With us, we have with us Pure, the chairperson IEEE Bombay section. I would request to first address all and inform everyone about the Student Congress, the recent event. So I'll just stop share. Anand sir, you can. Anand sir is there? Okay. Dattatreya sir, are you there in the meeting? Okay, so maybe he will join again later. So at that time, he will be interacting with all of you. I'll just share my presentation. Is the screen visible?
Yes, ma'am. Yes.
Everyone?
Yes, ma'am, it is visible.
Yeah. So we welcome you all for this STEM education volunteer training. And we also thank all of you for taking the initiative to be a part of this collaborative program of IEEE Bombay section, which we have been running since last 2 years. This is the third year that we are organizing this program. Last 2 years, the theme was Tech World. Basically, it was more of fun with physics. This time, the theme that we have set for this workshop is space education. Basically, now that has become like, or that interests the students a lot. And therefore, this time we have changed the theme with the space and satellites, I would say, and wireless communication. So that is the basic objective or the things that we want to deliver through this workshop to the young students. Anand sir has entered the meeting. Good afternoon, Anand.
Good afternoon, madam.
Yeah, sir, you will start.
Yeah, you can also start now, madam. I'm here only.
Okay. So I just started with the introduction, sir. So if you want to first brief about the Student Congress and to everyone, or should I start with the training right now?
I think Dattatreya sir also he is joining.
Okay, he's
So,
joining. Okay,
yeah.
by then I'll just share few slides before we go to the content. So maybe the introduction part I'll just take as what is expected and what we are doing till now. So Dattatreya sir has also joined.
So he can actually, you can.
Yeah. I'll let him first take it, then we will
Yeah,
continue.
please. I'm here only, madam.
Yeah. Good afternoon, Dattatreya sir.
Yeah, good afternoon, ma'am.
Yeah. Sir, you can first start. Anand
Yeah.
sir is also there in the meeting.
Yes. Give me 1 minute, ma'am. Just
Sure.
So, madam, this time how many branches are there for this STEM?
Can you repeat yourself, sir? I think ma'am hasn't heard.
Okay. No, I said how many student branches are there this time for STEM?
Ma'am,
15?
you're not audible.
You are on mute.
Oops. Am I audible now? Yeah. So 10 student branches.
Am I
Yeah,
audible,
yeah.
ma'am?
Yeah, I'll stop share. Yeah, you can. You want to share, sir?
No. I just,
Yeah.
yeah, I think. Yeah, so very good afternoon, everyone. With the permission of the chair, Anand Garpure sir, and also ESC activity chair, Dr. Lochanjoli ma'am. Thank you for giving me opportunity to interact with you all. So first of all, I would like to greet on the behalf of IEEE Bombay Section Student Activity Committee. I, it's my, it's my pleasure to inform you that that after 2 years of pandemic break, IEEE Bombay Section Student Activity Committee is pleased to organize the fully in-person IBSYWLC, which is IEEE Bombay Section Student, Young Professional, Women in Engineering, and Like Member Congress, which is scheduled from 23rd, 24th, and 25th. The venue is Anna Sahib Dange College of Engineering, Technology, and Asta, which is Sangli. When we start the planning of this event, many venue plans, like everyone think about the smart cities like Goa, Nagpur, Pune, Nashik, and Mumbai. But Mumbai having the space issue. But this time, under dynamic leadership of Anand sir, we thought yes, we should go some of the different places, and that's why we selected a Sangli. Now, people think why Sangli, because yes, this is a rural area, but I just would like to tell the location is very beautiful. I think the thing I would like to highlight, and that college having the good uh, infrastructure facility, the classes, the Wi-Fi. This also they have the special mini Olympic sports complex with the cultural activity. So it was really nice environment. So this is topic I talk about the venue, but what you will be getting in that 3 days, that is also very much important. So I just would like to highlight this is absolutely 3-day event, and where we have invited almost 20 plus eminent speakers nationally and internationally who share their knowledge and experience to the workshop, session, talks, panel discussion. And so basically, this Congress will be the guide to the enthusiast with the plethora of career opportunities available in diverse aspects. Also, it will act as a forum where students can ideate, collaborate. Experts would aid them. Also, you will get training for a volunteering. This Congress also help you young minds go on their soft skill, including presentation, communication skill. The events are planned. The fully packed event, 3 days, is absolutely the stay event. And apart from this, there are many other activity also we have planned. So morning 9 to evening 5, there is the plenary session. There are parallel tracks. In parallel tracks, we have the 4 tracks. All full tracks are absolutely full with the eminent speakers. The first track is the student track. Second track is the young professional. Third is was life member, but with the permission of office bearer, I have changed to the specifically the faculty track. Because what we observe, many faculty are joining for this Congress because this is a combination of women, young professional, student, and the faculty members. Now you will say, sir, it is just you're talking about the sessions, technical sessions. But what about other activities? So every evening we have the sports activity, which is a very beautiful mini sports complex. and on a first day, where also we'll be giving the some of the prizes. Then second day we have the cultural night with the first the cultural where the participant or the speaker, volunteer, organizer will perform the drama, dance, whichever their hobbies. And at the end we have the DJ night and there's a gala dinner. So one more thing I would like to highlight. Recently, just 2 days back, we got official permission for industrial visit. The sugar factory is the asset of the Maharashtra farmer. But what is this sugar factory? Many times we hear in the news sugar factory and sugar factory production, many things. But what exactly inside a sugar? Uh, how many months their plant is usually in active phase? Many things. So all these things you will personally look by visiting the one of the eminent sugar. This event is planned on second day after the lunch, post lunch. And I also Anand sir and the office bearer. Why can't we have the IEEE Bombay section awards? Because all students, all faculty members, all affinity groups, different committees, uh, doing wonderful job. But yes, they also get appreciated by 3 agencies. One is our local parent section, IEEE Bombay section. Second is Region 10, and the third is IEEE headquarters. So basically, these 3 agencies are appreciating. Everyone agrees we are getting for the award applications. So a lot of awareness. So it's really one more idea of our honorable chair, Anand sir. And what we thought, we are also declaring announcement of all IEEE Bombay section student-related awards on the last day during the validity. So probably is the inspiration. Next time, probably next year, you will also apply for that and will observe a lot of competition. SAC committee, I take opportunity to invite you all. I think it is not forcible. It is like you should get motivated. You should ask to your branch mentor, counselor, yes, ma'am, why can't we join the IBS vitamins? So that's all. I think thank you, Lochan ma'am, and thank you.
Okay, thank you, Dattatreya. Thank you, Locha Madam, for giving this opportunity. So we have about 200 delegates who are already registered, and we have about 100 plus. About 100 are still we can accommodate. So we request us all, please try to join, and I can also kindly motivate your students to join, because this is a more of a networking event where they will cherish the moments. In fact, if I may relate, one of the attendees in 2000 student congress, and it has motivated me so much that I'm still there in IEEE even after 24 years. So this way it really helps in networking. People I met in 2020 or 2002, 2001 are still in contacts. Although that time there was no Facebook, mobile, there was still emails and SMSs, but it was still worth the trouble. So looking forward all to join. So I'll request Dattatreya to share the details in the chat box, so that if somebody wants to connect us for any further information, they can do so after this session is over. Thank you. Thank you very much. Thank you, Lochar Madam. Over to you.
Yes, sir. I will put it in the chat session.
Thank you, sir. So everyone, we would request all of you to encourage our students to join this Congress. And thank you all that I see a lot of student volunteers have also joined for this volunteer training. because the involvement only brings the connection with the students when you go to the schools. This is a pre-university STEM education initiative where we expect that the engineering colleges should connect with the students, and STEM education is the right way to connect with them. You has a theme of space education, satellites, and the wireless communication. So what is this STEM education initiative? As I have already told you, there is a need to develop strong science concepts, because right now it is seen that many times we find that the students, although they take certain subjects, but the connect is only superficial, and it needs to be in-depth connect. And this is the right way to connect it by giving them a hands-on practice and experiential workshops. So this workshop, we have divided, I would say, 4 parts. The first part is an introduction about the space and the different phenomena that is done with the help of a simulator training. Right now, the video recording of this session will also be shared with all of you. And it is through the sandbox, the training about the space. How do you explore the facts of the spaces through satellite? So a small presentation of how you can connect with what the students do, and then to make them actually do a hands-on. This time we would be introducing the small micro bits. They are the small processors which will help us to make us demonstrate to them. So it has a simulator part as well as the hands-on. So for hands-on, you may be requiring certain kits to be purchased as a part of components, the funds that would be. And for the simulation, it's a free software. And what is expected is which you, if you are going to the school, that school should have and a laboratory. In case they are not having, you can invite them to your use the laboratory of your institute. So maybe size of a laboratory where each student gets an access is around about to 40. So that could be the size to which you could limit the size of the students who can be participating in your workshop, but giving them the hands-on. After doing the simulation, the same needs to be on the microbits, and that can be experienced for see the things working wireless. Basically, the small microbits will help us only, and the rest part, if you talk about actually what are being transmitted, that could be a demo setup that you can make and tell them about how the bigger processors help us for maybe sensing the signals as well as sending the signals. So that could be a demo part of it, which would be done with the help of an Arduino. Definitely, when we talk about the school students, and since our target is from say 6 to 10, or the understanding to actually do the Arduino coding, because I have done some pilot projects. So that is a part where it is little difficult, and therefore we have removed that part of students doing any kind of coding. Instead of microbit, they will be doing the part of simulation, and there's just drop. So that part, since all are engineering students, they can easily develop and demonstrate you kind of say module or a Bluetooth or a Zigbee, any module, we would be demonstrating with an NRF module. Then after this, when you are demonstrating it, definitely for any workshop, it is important that what we have come out after 2 pilot, more input when a different set of students in the different parts of the state, like we have a lot of people from other parts, not only in Mumbai. So those experiential learning, the feedbacks are important for us. So that needs to be shared with all of us since we are now a part of a community and we need to improve every time when we go next time. Finally, since as a part of STEM workshop, it is not that we just go one time and do it. We would encourage you that when you are purchasing these kits, a pair of kit that is a micro bit could be given to the schools where you executing all your workshops. You can give one set that is a pair of a micro bit to any particular school where you are conducting. So this program, as you already know, this is completely sponsored by IEEE Bombay section. This time, previously, last year, we had prior, I would say, advance payment of it, but this time the policy has been changed and the payments will be done only on producing the bills. So it will be post payment, I would say, that the amount will be completely reimbursed. The amount is 13,000 rupees. An appreciation letter for the not only the faculty coordinator, but the student coordinator is also given by IEEE Bombay sanction. And the final report, when it is published in the newsletter, the mention of the colleges participating in this program is also there. So expectation is definitely this time we are completely focusing on component purchase. The full funding would be for the component purchase and one set for the each school. As I said, the majorly expenses would be on microbit and the sensors because Arduino is something which I think every college or even has it. So it won't be required that you spend on that, but definitely the microbits. These are the, is it visible? I'll be demonstrating everything just to give you a brief of what we are. I think, is it visible? Yeah, so these are the micro bits which has got these LEDs which you see as a matrix where the text can be displayed and has also got a radio that is a wireless transmission module. So that is how we can easily use it for small short distance when the students are sitting next to each other. They can definitely transmit one text being received by the other. So expectations from the colleges who are being given the sponsorship is active participation in IEEE Bombay section activities. Because this time, as many of you have applied and certain applications were rejected, the reason being first, that was the only reason I would say, was the active members. As for an active branch, 12 is a minimum number. Certain people did not comply to that. And also, the reporting of the activities on Bombay section, that is final report filing, was not done. Those were the criteria and the branches have been selected. All bills have to be with the GST in the name of IEEE Mumbai. Please do not use the wrong GST number. Because the problem I'm just saying, by mistake, it's not intentional. By mistake, certain times some GST is not matching, the name is matching. So we have to be very careful because all these bills get reimbursed only if the GST is matching and the name is IEEE Mumbai Section Welfare Association. You actually, I would say these two, this letter of appreciation, many times when we go and do this activity, the schools give an appreciation letter to the institute. It is definitely an outreach activity that comes as a credit to the college as well as to the students and the faculty. We expect that once you complete it and satisfactorily everything is, you can, we would expect a letter from the college about the completion. And you need to post your planning and the conduct photos on the group, because that helps us to prepare the final report when we are submitting it to the Bombay section newsletter. And we also provide you a Google link for providing us the details so that we have our records on the drive also. You need to send all the hard copies of your bills to me. And once, if any queries are there, that gets resolved at my level, and then we can share it with the Bombay section. For right now, we are in June 15th, 16th today is. By 31st of August, you can definitely share with us that, I'm so sorry, it's 22, it's 23, 31st of 3, that we expect the things to be completed. And also, you need to report all your activities on B2. It's getting added as a credit to your student branch, but we need to make sure that you report it on B2s on IEEE. So sample report I would like to share with you, and the bills reimbursement form, the way you have to fill it. There will be two parts of your bills. One would be with the GST and the other would be without GST. So you need to separate the two bills. The forms will be shared with you. Wherever your GST bills are there, there will be a separate bill and non-GST. But here, since we are expecting all the expenses on the components, all the bills would be with the GST. Then the report. I'll just share the report, sample report. Yeah. So the sample report will definitely have what is the event, where do you conduct it, how many participants were there, what were the objectives that you have set, what is the feedback that was given to you. Simple, maybe a 1 or a 2-page report that could be a summary of the activities, the people involved, and what is the outcome that you have achieved through it. Then lastly, yeah. Feedbacks and suggestions is something we would request to you to share with us, so that it is like a continuous process of improvement, and we every time learn new things and new ideas. And one more thing that I would suggest is that will happen only with the active participation of all is this journey of workshop should not stop here. We can have one event of where the students, school students and the engineering students come together and participate in and present a project. So that could be a project presentation where there is a combination of engineering, so that the journey of this learning, when engineering students go to the school and learn from there, it is continuing. It does not stop only after the workshop. I would like to share why this is important is, just to quote one example, we had one workshop where we were teaching conductivity. So we just told them this pencil is a conductor, and we had a pencil which was sharpened on both the sides. And with the help of an LED circuit, we just connected the two ends and showed them, see, the LED is glowing, this LED is a conductor. So that school was where some students were actually not carrying the pencil. So what one child did was, before he gave his pencil to the other, he just scratched on his, made a patch with the pencil on his paper and showed to me, see this, I have created a conductive patch on the paper. So this was something which would never came to our mind, but definitely it comes through their creativity and their thinking process that we also learned that this was another way of teaching them the conductivity when certain resources were limited in that particular classroom. So learning is not only from one side, it is like both the sides that we learn. Finally, this time, these are the 10 student branches who have been selected for the student STEM grant. Definitely, the reason being they applied, that was definitely the first reason. Secondly, they complied to what was expected as minimum count of the student branches, reporting of the activities on the portal, and finally, the final submission that was expected at the end of the year. That was done by these branches. The other branches who lost, sometimes they were having the count, but they did not report the activities. So make sure that those who are there in the meeting and did not get the grant, we have definitely the next phase, but that will happen if you are actively now participating in the Bombay section activities, reporting your activities, and maintaining the count of students. So thank you. If you have any queries. Any queries till now? So we can
Hello.
start. Yeah. Yes, Sujata.
Yeah, just I wanted to know, is it mandatory to give the workshop under the same umbrella on the wireless communication?
Yeah. This time we have fixed the theme. Every time the theme is fixed and the same theme is conducted across the section.
Okay, so it is about to satellite communication with respect to satellite communication or only wireless communication?
We'll tell you everything will go flow by. This was just a general flow. So one by one will come to what is expected. Is that okay?
So contents are given by you?
Yeah, everything is given by us.
Okay, fine.
Lochan
Sure.
ma'am?
Yeah.
I am Mini Rajiv here. Ma'am, I couldn't
Yeah.
see the list what you have shown.
Oh, was just a minute. Where is it? Was it not shared? Yeah. Is it visible?
Not yet, ma'am, but
Yeah.
it is not yet.
It's loading.
Yeah, it is visible now.
It's loading.
Visible
it's-
now.
Yeah. Okay. Was my slides not visible initially?
Other slides were visible, ma'am. Only
Okay.
this list was not visible. Now it is
Okay.
visible.
Oh. So we can start with the first part. That is, Shaurya, you can start sharing.
Lochan, ma'am, Anand sir has raised his hand.
Yeah.
Maybe
Okay,
he's
sorry. Yeah.
Anand.
Yeah, okay, madam.
Yes, sir. Yes.
So I just have one particular request for you, particularly to the ESA team
Yes.
as a whole. So basically, the STEM consists of your science, technology, and mathematics, engineering,
Engineering maths, yeah.
engineering and maths. So maybe our this whatever activities we have done till date could fall under technology and engineering.
Yeah.
Can we not think of something where we can also try to introduce mathematics to the students?
So definitely it can be
how-
done. It can be done.
So maybe,
We
yeah, next time maybe what we can do is we
Yeah,
can
yeah.
do, so particularly maths, it can be a virtual also, because there is no, but we also try to, try to reach each of every element of STEM if you really want to do the justice to it.
Yeah.
And
Yeah.
since,
We'll do it.
and it would be best if you can actually initiate the particular M part. M is very critical. Even I'm still afraid of N. I mean, I'm from Pune University. I know M3 was very difficult. So if we try to inculcate this M particularly from the students, it would be really helpful. Thank you.
Okay, I guess now I'll start off from explaining how the software that we use usually works. Okay, so hello
So
everybody.
this
I
is
am
a sandbox
yeah.
that he
Okay, I guess I'll continue. This is the Universe Sandbox, the software that we use to demonstrate the simulation that happen in the outer space. My name is Shaurya and I'm doing this from Astronomy Club of TCP. This is what we usually do in the events like Antariksh, where we give the students an idea about what is happening in the outside, outside our Earth, because everybody has their own imagination and they have their own sorts of understanding the astronomical phenomena. So what the main intentions of what we do there, okay, and what I expect everyone who will be conducting these simulations for the students, the idea is to explain those complex phenomena in most simplistic and correct way as possible. So when I say simplistic, that means obviously we can eliminate a lot of different mathematical and physical things which might not be of that much not use, but in the understanding the spectrum of the kids. For example, I cannot explain the students about how relativity causes gravitational bending of light, gravitational lensing of light. But I would use some another example to explain them the basic meaning of it. So this is what I mean by that. This is a simulation that we use. The idea is we usually go with a pattern. So it is more like a story because what we have personally experienced. We have also done things which were not in order before, and we have also been doing events which are in order. Now, when I say order, that means we have a script, sort of a script, where we not randomly, but in an order, we go with the life cycle of a star. Okay. So star is something that everyone can connect with. Everybody knows what a star is, and they have some basic idea of how it works, how it doesn't work, and the whole life cycle process of it. So we start off by talking about stars. Okay. General idea, we take sun, for example, here. We talk about sun. We explain why the star looks like it is. Okay. So this is some general question. I would love if somebody in the comment chat box would give the answer. So there are two stars. One is blue and another one is red. Which one do you think would be hotter? Okay, perfect. So Saurav has replied blue, which is an amazing answer. So now the idea is exactly. Now the idea is to make students understand why the blue star would be always hotter than the red stars, right? And explaining them in now you don't have to show them the black body radiation curve, but then somehow make them understand how electromagnetic radiation works and in that sort of way. Yes, Sujata ma'am, you have a doubt, you can ask right away. Hello, I'm audible, right?
Yes, yes, Shaurya.
Yeah.
you can
Continue.
continue.
Okay. So I'll continue. This is the basic idea when we talk about stars. We talk about how they are formed. Okay. But then your content should completely change according to your audience, just how most of your professors who give lectures to students have different grades. So you would know that better than me. But what I basically mean is that it was a previous query. Okay. What I basically mean is that if my audience is from 6th standard to 10th standard kids to 8th standard kids, then I would represent them star as a ball of fire. That's what I would represent them as. But if I have students from 9th standard to 10th standard, then in their physics, they are now, they know about nuclear fission and fusion. So now I can use things in more accurate sense so that it's even better for their understanding. So this is the idea of stars. Now in this software, it's extremely interactive. So when you tap on a star, okay, for example, this is Sirius, the sun, okay, sun is, okay, Sirius. Yeah. So as you can see in the right side window, you get the name of the star, then the mass in terms of sun, because in astronomy, the masses are always compared, and the luminosities, they're always compared in terms of sun, with respect to sun. So you get all of these information on the right hand side. Okay, and these are like very basic information. What you can do is you can also alter these basic terms. Okay, for example, you can increase the speed or increase the radius or anything of this actual star and see how it changes. So let's show them this the radius. Okay, so you have now increased the size of the star. Now probably this is not in a simulative environment, but if I put it in a simulative environment, then whatever changes that I'm putting on the right hand side window would also physically affect the things around this specific star. So right now in this sense, okay. So due to, I guess, the increase of gravity, it slingshot the sun, around. So it threw the sun around, and yeah, that's the beauty of this basic software. So you can ask students what they want to see, what they want to visualize gravity as. So for example, if you can see this specific thing, the sun moved because the sun is 8 light minutes away from us. So the sun moved, and then after all of the planets started moving, because you can still see the sun. That means you can still feel the gravity for at least the first 8 minutes or seconds of it. And after that, it will affect you. Light is faster than gravity, gravitational waves itself. So this is like the basic about sun. Now, if we change it from sun to, let's go to an exploding sun, okay, a supernova. Not just sun, but any star. So this is your simulative window, right? These are all of the simulations that you would possibly need. You don't have to actually create your own simulations, but you have a feasibility to do so if you want to do something out of the box. Here we have these simulations that you can see. So they have supernova of sun in the solar system. Now this is supernova, the sun in the solar system, right? So our sun is exploding. Now this is the basic information. We can just, yeah. So okay, can you just stop it? No, just go back in time. Yeah, so this window is very important. So you need to know how to work with time, right? So you have to there will be a lot of simulations that are happening in real time. And if you're seeing sun exploding in real time, probably you'll never be able to see the explosion. So you can change, you can somehow, change it by, this is minutes per seconds, right? Now you can go with this years per seconds and everything. So now this is real time per second. If you just change it to make it faster, so we can go to hours per second. So every second here is representing hours there. And usually for these simulations, can we just proceed? Yeah. Just go with years per second. It'll be faster, yeah. Okay. So this is like every second represents a year, right? Now all of the stars and planets would move if you play this. Okay. Yeah. Okay, we couldn't see the supernova explosion. Okay, so this is the whole supernova explosion. It happened really fast. Amay, can you just speed? Yeah. So you have to ticker it, obviously. We're going to show it in a way, yeah. So this is how it's happening, right? And this is how we explain kids on the projector, and sometimes also on virtual reality simulations, where they experience being in space, understanding the whole scale at which these things are happening. So these things are not happening on a very small scale. They're happening on a gigantic scales, or even sometimes till light years across. As you can see, the supernova itself would spread outside the whole solar system. So the whole solar system would be inside the supernova. And yeah, that's the beauty that we want to explain the kids, to understand at what scales these things are happening. So this is the solar system, the supernova simulation. Now what we go with, because now we have a star and it has obviously collapsed in its own gravity, so we explain them how the supernova is happening. Now most of you professors would already be aware about it. Still, I would give a basic idea, because this is how I would teach to the kids there, that we explain that it's a war going on, the war between gravity and the expansion. Okay, so because of nuclear fission, okay, and at the same time the gravity, which is causing nuclear fusion. There's this two forces that are fighting with one another. And because the sun is in a very good shape, it's only because of the fact that the forces are balanced. But there will be a time in future where the sun would have already used most of its fuel. And once that fuel is gone, then obviously one side is losing and the other side is winning, which would basically cause the sun to explode because it will be collapsing under its own gravity, and then it would explode. So this is what we explain it to the kids, obviously in more simplistic way, not the way I just delivered it. So that's the idea. Now we go to one of the most famous topics, black holes, because mostly kids have watched movies like Interstellar, or they are fan of science fiction and things like that. So they are mostly aware about it. So you ask a kid. So this is the point where we have to keep our interaction to the maximum, because kids themselves have a lot of ideas that they want to deliver. And if it will be more like a lecture where I'm telling and they're listening, then I'd really lose a lot of attention from the kids. So what we do is, this is the time we start, we get bombarded with the questions and answers and their own idea of what a black hole is, and how does a black hole form, and how it's affecting us. Does it affect us? And asking these questions that might intrigue them to think and answer. And some of them answer in very brilliant ways. We had students who ask very simple questions which are really tough answers though, so you need to come prepared. But so talking about black holes, so this is the simulation that we show to about black holes. The idea of a black hole is, obviously you can't do much around it, but what we do is the background stars that you see. Amay, can you zoom in a bit? Yeah, okay. So yeah, exactly. So if you can see the background stars, they are all creating this whole pattern. They're moving like water, okay, around it, which we call the lensing effect of gravity, which basically means, as you can see, it feels like you're moving a convex lens all over the surface of a paper, right? This is what you see. And this lensing effect is due to, obviously, gravity bending the light. So the light that is behind the black hole, it is bending around the black hole and then falling into our eyes. So this is the apparent image that we are watching. Now, we need to explain to the kids, what is this, how is this, and we have to break down this whole gravitational lensing and things like relativity in a very simplistic way. So I have my own examples that I deliver, and I think every professor would have their own examples to deliver. The way I deliver is, I use an example of a car moving on a road. So I think I tell the kids that the road is space and the car is the particle of light. And this is just a road going on, and on the left and the right there's water. So you can't actually drive into the water. You have to follow the road. And if the road takes a right, you don't have any choice. Your car has to take a right. Otherwise it will fall inside the water. So your car has to follow the road. In the same way, the particle of light follows space. Okay. And what black hole does is, actually, it's a hole, right? It's a hole in space. So what it actually does is, it pushes the fabric of space in this way. And if it is actually pushing the fabric of space, then in the same way, the light would also be bending, because it is moving like the car is moving on the road. So in the same way, the light is moving in space, which is bended. And that's why you can see all these deformative images, because the black hole is actually bending space around it. So this is how I explain it. And you'll get amazing examples to deliver it to the kids, because kids only work with examples, is what I have came across. You can't just give them formula or something like that. So yeah, this is where we end usually our simulation on black holes. Now, you can do a lot with black holes. This is just one black hole, which is, around sun. And I guess it has one solar mass, if I'm not wrong. Mike, you can open your camera. Okay, it's 100 solar masses of black hole. So that means that it's so much smaller compared to sun, okay, in size. But then its mass is 100 times that of the sun, okay. And yeah, that's the beauty of black hole, and you need to explain all of those phenomena in that way. So this is what the simulation of black hole is. Now you can create your own black hole. You can throw things in a black hole. We'll just show you. Amay, can we throw something at something, like moon and collision of anything with anything? Even moon and earth would do. So when we are done with our content and we still have time, which usually never happens, we ask kids what is their fantasy, their own fantasies in space, regarding space. And just a second, I'm sorry. So their ideas sometimes. Okay. So sorry. What's going on? Okay, am I still audible? I hope I'm audible.
Yeah,
Yes,
you are
yes.
audible.
Yes.
Yeah, okay, thank you so much. What I was saying is that kids have their own fantasy, you know, of a ship. What if I'm in a ship and I'm going inside a black hole, a spaceship, and throwing one black hole at another black hole? What happens if two black holes collide? And what would happen if the sun gets big enough to touch the surface of Earth and moon collides with Earth? So we also show all of these simulations because we can, obviously. So yeah, this is what mostly Astronomy Club does. And this is where we end. And then we somehow create a way for the satellite team to come in. So there's no, you know, students understand that everything that we have made the simulation from, all the data that we're collecting, it all works on the basis of data. And in space, from light to throughout the electromagnetic radiation, everything is data that is collected by satellites. So we give examples of James Webb Telescope and Hubble Telescope and how these are satellites plus telescope. And then we create a way in for the satellite team to come in. So we show images of, like, for example, Hubble and like physical satellites in some way to bridge the gap, and then the satellite team can come on and then they can demonstrate their own versions of things. So this is what mostly we do in the simulation. If somebody has any doubt, please you can ask me right now. Okay, I'm assuming. Okay, there are no doubts. That's amazing. You can get this software. None of you asked, but you can get this software either for free, okay, and you can buy it on Steam. Okay, on Steam Engine, you'll get this software, and you can also get this software for free. There are a lot of websites that are available that you can, you know, get this from, cracked version of these. But if any of you are going to do any event that would be having VRs, virtual reality, and softwares like Oculus Quest and also now the new Apple Vision Pro, if any of you would be having them and you want to use it, because students love to wear the VR and experience space inside, then I would recommend to buy the original software, because the cracked softwares won't work. Like, you have to buy a software with the VR itself. So so then you can also have more interactions with the kids. This is an activity that we have already done and kids loved it. So it's another intuitive and, you know, interactive way to understand kids about space and the entirety of it. So if anybody has any doubt, I'd appreciate it.
We'll share the link from where you can get it for free.
Yeah.
Because this is all about your imagination as your curiosity. This is basically your curiosity and how did you, means basically going into the space and seeing. So we start with the questions only and what they want to know about the space, and these kids keep on demonstrating them what they want to know. And that is how the interest gets created, and some good the way the life cycle of a star, as he explained, the black hole and other concepts, they are explained through the way of simulation. So here we stop the first part, I would say, of our workshop. Sure, you can stop share. Yeah. Thank you.
Yeah.
Now, after doing this part of what it is, what is there in the space, we go into the basically how this. I'm so sorry. Yeah. Then we go into how this part is basically captured into the space. Definitely here we introduce them to the concepts of satellites, like basically because it's not something which is coming as a surprise to them. Everyone knows about satellite. So we just start with where have you seen, where have we used. So taking some examples of say Galvan Valley or some movies, we just try to connect them with the scenarios where they know. Definitely the first example they all know is GPS that they are using. Along with that, We talk about the various stories, I would say. That is what we try to connect them with, and Pathankot and all that examples we take it, so that we connect the students with what is a satellite and its application. Definitely most of it that are listed with respect to the military applications. And definitely you cannot proceed without giving the credits to ISRO. All that India is doing today in the field of satellites is because of the ISRO. And we talk about certain achievements of the ISRO to connect them with, definitely they know about it. We just tell few stories related with the achievements of ISRO. And then a basic principle, this is where we try to introduce them with wireless part that we actually want them to have a hands-on on, that is a communication link. And maybe some videos could be, we have inbuilt in, means we have kept in it too, because the launching of a satellite is always most interesting. And that is what we have tried to incorporate in it, so that they understand that, because this is a story, I would say, of a satellite, which is very interesting. So that is a part that we have put. Then definitely some of the things that they already know, and maybe few more things you are talking about, is this definitely not required. After GPS, you can talk about the Indian navigation system, that how ISRO is contributing with the help of our own local system. And yeah, and then these things I will just delete. Huh. And then definitely this is like, where is the future and how we can use it as the satellite, means basically taking from wirelessly controlling, communicating, transmitting the data, videos, and images. So this whole satellite ka part is just to connect them, is how these data are collected and transmitted to the earth. There's no wired connection, but wirelessly we are transmitting all the images, everything we are getting transmitted, and that will have an application in future also, with GPS being one of the controllers in various future devices. After that, this is just, we want to basically, if the duration of a workshop, if you say, is of 2 hours, normally we prefer 2.5 hours, that the slot normally before break or after break, that the schools give us as a part of conducting it. So 2.5 hours, more than that we don't get it. So we need to plan it like we are, this is like basically setting the background, motivating them to understand the things that we want to teach. And after that, we can just tell them that let's now build up a wireless, I'll just, yeah. We can directly, if definitely this expectation is you have to conduct it in the your laboratories or the laboratory of a school, which definitely has an internet connection, because this part has to be conducted there. You can just make them, this is very simple simulation that each one will do, and they will also enjoy it. They can go to this make a code, microbits. So microbit is what we are using, and then they will make a new project. And we can just teach them, as definitely we are talking about radio communication here. So all the components will be taking from the radio part of the microbit. So we can just teach them as what is setting a group. Setting of a group is basically like how many devices you want to communicate with each other. So the number of groups they would be forming, they will be communicating with each other. Then what do we want to send it is, Now this microbit has got two buttons A and B. So what we could be demonstrating would be on action of A, what has to be done or what could be wirelessly being transmitted. Definitely it is restricted to text. And so we have two buttons. So two actions we can demonstrate to them. And then we can like, what is that we want to send? Say we want to send a string. All these videos we will be definitely sharing. Say in the first we want to send yes, and in the second button we want to suppose send no. And here on receiving means basically this is for receiving the data. On receive what we want to show. So we want to show a string. So what would be the string? String that you are sending that has coming basically into the received string. So for that they need to define a variable which should have the same spelling as is there. So we'll just drag and drop it here. In case there is a spelling mistake, now you will get an error. Please be cautious that this is just a simple thing. 4 steps the programming is done. They can just run it and see. So it becomes easy for them to. So once you click your button, because we are using radio, automatically the second microbit appears in the simulator. And say we are pressing 1. I think when I'm B. So this is just a simple way of demonstrating a simulator, which each child, basically we want to engage that every child is doing. And then this, you see the download button. This download button, as I have already showed you initially, this micro bit can be connected to your laptop like a USB and like a USB, and it can be, you can simply click on the download, connect it with microbit, and the data gets, or your program, basically this code gets embedded here, and it can work independently by using these batteries that comes as a part of it. Like basically without any computers, they would be working fine. So you can just make them download, or in case you don't want to waste the time there, because kids take a little time. For us doing it will take hardly more than 5 minutes. But when you are explaining them another thing, it may take a little more time. So in case the time is a constraint, you can means already download and keep the microbits ready. The only problem that you sometimes face while using and is not getting connected to the microbit. So in that case, you need to actually use the maintenance mode of this microbit, which is like just click on this reset button which you see on it and connect. Means USB के साथ the same way you connect it, and now आपके download say you can take the file and load it, and the things are already done. And simply it will easily it will be showing you the demonstration here. I'll just show you the demonstration part also, so that we'll be sharing that also. Just a second, I missed on. Okay. By the time it's getting downloaded, we come to the last part of it. Means definitely I'll just checking maybe some internet problem. It's not getting loaded here. So after that, it's like you have already done, you have explained them about, you are means talking about wirelessly and how it is important or why it is important to have this wireless connection. And how it is important part of your any communication. And after that, maybe when you have already talked about, since the space was the theme, we just talk about a simple circuit connection which wirelessly transmits the sensor data, that is a temperature data. So that could be only the demo part, which you definitely are not expecting the students to get engaged and means do the coding, but you can actually make your setups ready and demonstrate it, so that and show them definitely if there could be a part near the window or somewhere the temperature difference or the humidity differences could be shown. So Niket, if you could share that demo, the code we will be sharing with you. Niket, if you could share your
Yes,
screen
ma'am.
and show the demos.
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Hello, students. Is my screen visible?
Yes, sir. Yes, sir. It is
Okay.
visible.
Okay. Thank you, ma'am. So, students, so here we will be, as ma'am told, that we have created one sensor. So here we are using NRF module. So it is NRF24L01 module. So what is the specialty of this module is that it is a wireless transmitter. See, this is how it looks like. This is a wireless transmitter and receiver. And the effective range of this transmitter receiver is around 300 to 200 to 300 meters. So what we can do, we can set up, we can connect, we can upload the Arduino program here, and then we can connect this to a 9-volt battery, and we can set up and we can put this module in a balloon set. Let us take an example of a balloon satellite, which is a balloon which is at the altitude of say 200 meters or 300 meters, and from there we can capture the real-time data of the humidity and temperature, and then we can send it to the ground station, that is the base station. So here we have made this is like one transmitter and this is one receiver. And once we make this transmitter and receiver, right? So here I have taken this example. Here we have connected this to the PC, transmitter and receiver. This is how the transmitter and receiver will look like. So we can keep one transmitter in a balloon set, which is at height of 200 meters, and one is at the base station, right? So I will just show you the demonstration. So I am using the AnyDesk. This is my AnyDesk PC. You can see this is my AnyDesk PC. On the AnyDesk PC, I am running this receiver program. So this is my receiver program, and this receiver program is receiving some data, right? So this is the receiver program. So now the PC which I am sitting, this PC is having this program. So this is the program. This is my PC, and this is the AnyDesk PC. Right. So this is the program. So here I am transmitting some text message. So if I want to change this text to TCET, so I have changed this text to TCET. Now I will be uploading this program in my Arduino board, and my Arduino board is connected to the NRF module, and this NRF module will transmit this message, hello world, from TCET, and this message will be received here, which is AnyDesk PC, which is a remote PC, which is kept at a distance, right? So I will just run this program. And once I run this program, it is uploading, it is done uploading, and now you can see the message is changed from hello world.tcet. It was ENTC earlier, now it is TCET. And you will wonder this why these special characters are coming. This special character is coming, see, because of the noise. So when you're transmitting the signal, wireless transmission, so there is some noise in between. So because of that noise, the signal gets distorted, right? So that is why we are getting these distortions here, right? So this is simple transmission of text, but as we have taken example of a balloon set. So the balloon satellite will definitely have a transmitter and receiver, and we will use this DHT11. We are using DHT11 sensor to capture the temperature and humidity data, right? So once we upload the program here in our PC, I am uploading the program in my Arduino, right? So it was simple text transmission. Now I have uploaded the program of temperature and humidity, and now you will see that at the receiving end, you will see that temperature is coming as 27 degrees Celsius, and the humidity is coming at as 52, right? So this is the receiving station. So this is, I will just move this window. This is the AnyDesk ID, and this is the receiving station. So right, so we can make a small balloon satellite, and we can demonstrate the use of satellite communication like this by capturing the sensor data from the altitude of 200 to 300 meters and transmitting them on the ground station. Thank you. That is all from my side.
Yeah, thank you, Niket. So please stop share. So this is the whole flow of the workshop that we have set. And basically, I would say that we actually have done the pilot and found that space is a theme, because previously we were doing this fun with physics that was called as the Tech World workshop, which we were doing since last 2 years. The connect of the students here, the connect of the students is a lot, because you will experience that the students ask lot of questions. It's not that they would be one way just at the receiving end, because space is something which is very interesting, and the students have lot of queries, lot of questions, lot of basically the questions which means they that comes to their mind, and definitely they haven't received any answer to that, and they get connected with this particular way we have conducted. We have conducted 3 pilots, and the way we could connect the students, definitely it helped us to every time. It was not the what we conducted the first time, it's the same version that we are presenting before you. Every time we have done it, we have improved it. So if you have any queries, you can ask. We have Mr. Ramni Kalra, also the Vice Chair of EAC. The board really, so he has been promoting pre-university education. So after, because definitely this funds that we are providing is restricted to the theme that is approved, because every time the theme gets approved at the Bombay section, and the same is percolated through this student training. There are other platform also where, I means, if you have done certain, or like Anand sir also talked about maths, taking maths as a theme next time. So we as a team could develop a new program. Definitely since I told you, the slots that the school gives is before the break or after the break, which is not more than 2.5 years. So if we could set some workshop for the next year together, it will be great. And Ravnik would be sharing with you some more resources where if you have your own workshop, you can actually contribute, or you can learn from there and build up your new workshop. Over to you, Ravnik.
Sure. Good afternoon, everyone. Ramnik this side. So first of all, congratulations to all the student branches, 10 student branches for getting the STEM grant. And it's always great to see STEM activities happening around different IEEE OUs across the regions. And being the board member in IEEE Pre-University Education Coordination Committee, it's my sole purpose for the last, I would say, 7 years. It's being in IEEE for me, and understanding and bridging the knowledge gap between, what should I say, bridging the knowledge gap between pre-university and the university, and along with giving those resources from the industry to the school students. It's what I guess we volunteers, being an IEEE member, are there to do. So for getting started, I will just share you more information about what are the different resources you can use, what are the different ideas across the globe, across different IEEE regions volunteers are doing, which you can just connect with them, uh, do addition of them, or replicate the model what they have implemented in their section, in their IEEE OU in Bombay section, as per your interest and as per your exposure to the nearby schools. Let's get started by listening to our past IEEE president, Kethiland, what she talks about IEEE Volunteer STEM Portal. I hope many of you must be aware about it. IEEE STEM Portal is a website of tryengineering.org, where we have different resources for school students, school parents, like parents of school students, and teachers, as well as volunteers. So these are the 4 audience which we target in Try Engineering, and we have different events, different ideas, different workshops, different quizzes, different games, all those type of resources which you may require while you are doing STEM volunteering. That is all ready-made available there. You just need to download them, download the lesson plan, take it up. And as Anand mentioned in the beginning, that we need to focus on each and every character of STEM: science, technology, engineering, and mathematics. And that's what you can take the help of. So let me quickly share a video. Just give me a second. And let me know once you are able to see the video. Are you able to see the browser? Second. Do I have a chat window? Yeah. Team, are you able to see the YouTube video?
Yes, we
Okay.
can see.
Perfect. Thank you, ma'am.
Hi, everyone. I'm Kathy Land, the 2021 IEEE president, and I want to thank all.
I hope the sound is also coming, right, Lochan ma'am?
Yes, yes.
Okay, perfect.
All of you for what you do to advance technology for humanity through your efforts to support pre-university STEM education. One of the most rewarding aspects of being an IEEE volunteer is conducting an activity that inspires the next generation of STEM professionals. Looking back at my own experiences, there is nothing more satisfying than seeing young faces transformed when they learn about engineering and technology. Delivering STEM outreach programs builds an appreciation in students for what engineers and technology professionals do and how they impact our lives while generating an understanding and excitement about STEM careers. We understand that IEEE volunteers are a direct connection between the profession and engaging these young students. We want to assist you in this important mission. IEEE supports pre-university students and teachers across the world through tryengineering.org. And now, I want to introduce you to the IEEE Volunteer STEM Portal, an additional resource that extends this support to you. IEEE built the Volunteer STEM Portal to help you as you engage in pre-university STEM outreach. The portal is a centralized resource for volunteers and IEEE operating units, such as student branches, chapters, sections, and technical societies and councils, where you'll have access to a searchable library of STEM programs being run by engineering and technology professionals just like you. It includes activities along with how-to resources to make it easier for volunteers to develop and implement STEM outreach programs. The portal is for volunteers who want to share, give back, and inspire the next generation of technology innovators. It also provides a place to collect data and understand the impact the IEEE community is having on pre-university students and educators around the globe. This STEM portal will be the foundation of IEEE's pre-university STEM outreach efforts and give volunteers a chance to learn from and support one another as they engage in STEM outreach in their local communities. Here's how you can use the portal. Browse some great STEM programs to provide you with ideas to adapt for your IEEE unit. Discover what STEM outreach events are happening in your region so you can make connections and build your local STEM community. Showcase your STEM programs to give other volunteers ideas. Share your results to help us measure IEEE's impact. And learn how to take your STEM program to the next level with proven strategies and quality resources. The portal is about working together and drawing on the experiences of others to help make your program a success. So be sure to share your knowledge, insights, and experience with other volunteers and the results and impact of your programs. We've even created a new IEEE pre-university STEM Collaboratech community for you to discuss your outreach journey with other volunteers on a global stage. Join us on this important mission, and with your help, the STEM portal will leverage our collective strength to inspire the next generation of STEM professionals.
Awesome. So that's kind of an overview of Try Engineering STEM portal from our past IEEE president. And when we started this during the lockdown to spread the message across different regions, we had a wow factor and wow reach out by different IEEE volunteers across different regions. And when I was exploring the database of Bombay section a few weeks back when we announced the STEM grant, and I was amazed to see that we at India Council and Region 10, we have grown so much in STEM outreach, which is really astonishing. And we are providing those support from Bombay section to help you out in your IEEE student branches to go ahead and reach out to the nearby schools, nearby your student branch, to collaborate to make them understand what actually STEM meant by and why that STEM knowledge is so required at their early ages, from 8th class to 12th class or whichever you're going to focus on depending upon the activity. Now let's give a quick recap of what Try Engineering portal is. So if you just open IEEE this tryengineering.org, I will share the link meanwhile in the chat window as well. So we have 3 types of resources here. This is for school teachers as well as college teachers who are focusing on to getting the resources to teach pre-university students. Here by pre-university, I mean school students. And we have students, so the school student directly, if they want to explore about different engineering fields, games, educational games, the one which we just saw, the space sandbox. It's a wonderful example of what we are actually there to expose being a volunteer to the students. And the third one is IEEE volunteers, as we all. So let's go one by one just to understand. So if I get into teachers, so you can see different tabs here: lesson plans, teacher resources, feature article, and FAQs. So if I go into lesson plans, we have different type of lesson plans. Anything if you wish to collaborate and if you wish to connect with these creators, you can directly open the lesson plan and download it. There's a ready-made instructions, workshop instruction, how to follow all these lesson plan. Download the PPT, which you can right away use in your classrooms when you are doing a STEM activity, being a volunteer. So let's take an example of, let me type math. So one of the concept in mathematics is complexity. So if we go into it, so we will able to see different kind of materials and preparation, what kind of things we require for this hands-on activity. So what is the design challenge? So basically all the lesson plans in Try Engineering portal is based out of design thinking or project-based learning. And that's how the lesson plans are being molded, because they are already running and learning theories in their academics book. How we can change it, being an IEEE volunteer, this is what we actually get towards engineering design challenge or a design thinking approach. Talking about activity instruction and procedures, for you as an organizer of the activity, you can just explore what are the different steps to follow while you're explaining the concept to the students. And if you go down, you will see the process. So we have a video as well based on this lesson plan that you can play in the starting. Then some of the background concepts. Now, even if you are not a mathematics teacher, or even if you are not aware about complexity subject, being IEEE volunteer, we in the lesson plan give you that resources that you can understand what this concept is all about and how you can deliver right away in front of students. Now, if I show you curriculum alignment, so what are the different curriculum organizations or some of the syllabus which is actually mapped with this lesson plan, this is also being given. Then some of the dig deeper. So let's say if some of the students are so much interested to explore what's after this, so you can share those things. Coming to the student worksheets,
I think Ramanik sir is
Is it
disconnected. Yeah, he's disconnected.
yes, sorry, I guess I got detected. Am I audible now?
Yes, yes, sir.
Yeah.
You're audible now.
Oh, sorry for that. Yeah, let me share my screen back. So yeah, we were talking about, yeah, it's now, I guess you are able to see my screen.
Yes, sir.
So we were talking about complexity. Yeah, sure. Thank you, ma'am. So this is how, like, we have a specific age level, we have different concept, what we're going to cover. So you have to just send out this information, who you are, and then you will able to download the lesson plan right away. So this is one of the wonderful resource which you can right away use. And coming to the teacher resources, so these are the different things, like even you can download certificates as well. Like for the school students, you don't need to work anything. Like we being IEEE, you need to sit with your designing team, make them the template and all the stuff. So that also you can directly do that. Okay. Coming to the students, so let's talk about Try Engineering Students platform. So they can have different kind of educational games here, and they can explore different type of engineering fields. Let's say computer is what some of the students are interested, so they can visit this page. They can explore what kind of future they have, what is the life of a computer engineer, and different kind of how to prepare for computer science, what are the different employment opportunities and companies, hyperlinks, and all the stuff. So this is one of the part which school students can explore, or being a volunteer, you can just take this material and showcase to them. Now coming to ourselves as a volunteer, that's where we have a portal called as IEEE STEM portal, which has all the required resources what you want. Now talking about the events, right? We were talking about how we can replicate others event. Well, let's say if I get into a camp, so we have different kind of categories. Now this is also the same thing. That's what Lochan ma'am was mentioning in the presentation. When you do an activity in IEEE student branch of yours for pre-university, go ahead and fill out the V2's report, very much necessary, and you will find these categories in which category you are going to report this STEM activity. Now, talking about camps, so we have different kind of camps. IEEE Epoxy Solar Camp is one of the camp which was conducted within the Bombay section scope. And you have all the contact details, you have the program description, what was the age focused on, and what are the different learning opportunity, and what is the implementation guide, how much volunteers do we need, what is the budget was focusing on, what are the material and supply. So every single thing of a program which is being conducted by volunteers like us all across different parts of world, you can just use that, connect with them, and replicate it in your own IEEE OU. And talking about resources, that's the main part. I see a lot of lag in a lot of IEEE student branch when they actually approach to their leadership to ask, hey, can we have the logo? Can we have the certificate design? Can we have something? So you don't need to worry about at all, because in the STEM portal, you will get it right away. So you see this volunteer STEM portal user guide. In this, you will get to have design toolkit and everything. So we have the visual guidelines, we have the survey question. Let's say you do a STEM activity, right? You don't need to worry about a survey, how to create a survey form. You have a sample survey form here right away. So this is the visual guide. You can just download this, and you will able to see what are the different engineering portal. So whatever event you are doing under STEM, obviously that will be reported to your student branch as a part of section, and as well as part to submit, or whenever you do reporting of V-tools in L31 reporting on V-tools, you can go ahead and use Try Engineering portal and submit your program after getting into volunteers, and you will see a option share your program. And that's where you can fill up your whole form. There's a submit now button, and it will ask you all required details, and that once it is approved by the global team, it will be displayed on the STEM portal. That's how the simple flow is. Now, this was the part of Try Engineering. Now, talking about another resource, which you might be, many of you might be aware about, which is kind of a very old program, and I've been following this a lot during my student branch days. So V-Star, Women Engineering Star program. This is also another kind of collaboration with IEEE Women Engineering, which you can focus on. And you have V Bombay section, Kavita ma'am and Rishali. So you can just connect with them to know more about it. And obviously V-Star is a collaborative platform with Try Engineering at directly. And that's how you can find different resources. I will share this as well with you in the chat window. And with that, that's all from my side. If you have any questions regarding pre-university, education, volunteering, anything, feel free to ask.
Thank you, Ramni. In the end, I just request all of you to please switch on your cameras so that we can have a photo, as well as a feedback form is shared in the chat window. I request all of you to please fill that feedback form. It is definitely, as I said, the journey of learning does not stop everywhere and every time. We learn new things when we interact with each other. That is the importance of such session. Thank you so much. Sukriti, are you taking the screenshots?
Yes, ma'am. Yes. Just wait for 1 minute so that.
Yeah. So everyone will switch on.
Okay, now I will take the
Yeah,
snap.
you can start
Yeah.
taking. All right.
Yeah. Thank you all. Thank you so much.
Thank you all for joining. And in case you have any queries, anything, we will definitely all the recordings as well as the material which I shared as a part of this meeting. We will be mailing it to you. If you have any queries, you can anytime reach out to us. We'll be there to help you out. And any other suggestions, if you have, please share with us. We will definitely try to incorporate. And as I said, the next step of